Hi, everybody. I think this is my little clicker here. We'll find out, though. My name is Mark Henderson. I'm from a company called Equilibrium. It's not that Equilibrium. I have to be fair and clarify. We're based out of Finland, and I'm from the Boston area. And I'm here to talk about something called Ziggurat, which is a network testing and stability suite and framework for your peer-to-peer blockchain network. And this isn't the clicker. Well, yes, it is. Okay, good. Okay. So I want to be really clear, and that I'm going to be talking about some downfalls and pitfalls of peer-to-peer networking, and I'm not picking on anybody, because we're going to talk about specific blockchain networks. Because the fact is, peer-to-peer networking is really hard. The best quote is the William Gibson quote, "There's no maps for these territories." Usually it's ad hoc, or it's inherited from something, like you'll inherit Kademlia from Kazaa, or you'll inherit something from the blockchain protocol, from the Bitcoin protocol. And you'll just sort of implement it and roll it out and not think too much about it. It has lots of moving parts. There's encryption, there's message passing. It's UDP, is it TCP, is it, what is it? And it's just one part of the overall blockchain puzzle, and you have to worry about a bunch of other things like consensus or tokens and things like that. So networking, sadly, can get overlooked sometimes. And it's the underlying base of everything that you do. Peer-to-peer networking is critical. And yet, it's where it is in your mind. So we came up with this sort of idea of the Ziggurat, which, if you're not familiar, it's a stepped pyramid. And each layer in the pyramid is going to support the layer above it. And we, at Equilibrium, define these three layers. It starts at the bottom with conformance. If you're lucky enough to have a networking spec, the first thing is conformance to that spec in your node implementation. Above that is performance, which is going to be, are there bottlenecks? Does the thing perform under scale when you have thousands upon thousands of nodes running your blockchain network? And above that, unfortunately, you have to deal with jerks in the blockchain network, malicious actors that are going to try to do bad things. And is your network going to be resilient to those things? So that's what we're here to validate and here to figure out. And this is our story. In 2021, it started with Zcash. We got a grant to do exactly that, to test those three layers of the pyramid with that. And it built into Zcash 2.0 grant. Now we're working with Ripple. And if you guys are really lucky, we might work with Polkadot. We have a Treasury Proposal going that we're going to submit maybe tomorrow. So keep an eye out for that. You should visit our booth, and we'll let you know when that lands, and you can vote on it. But where'd my slides go? There they are. So in the beginning, there was Zcash. I think it'd be useful if we talked a little bit about how we got the Zcash grant, because I think a lot of you are going to be doing proposals of your own, and I think it might be helpful to hear how we were successful. We sort of have some commandments here. One of them is the know thy network's government structures. So Zcash, and I'm going to talk a lot about Zcash because that's what we worked with, but this is all applicable to whatever Polkadot, Kusama, whatever network you're going to be working with. So Zcash governance is split into the Electric Coin Company, which is the for-profit arm, and then the Zcash Foundation, which is the non-for-profit arm that does the grants. That should sound pretty familiar to you. That's a lot like Parity and the Web3 Foundation. And you should know the important events that are happening in the ecosystem. At the time of our grant, they were writing the Rust implementation of the Zcash node called Zebra. And we were able to schedule a call and, shockingly, just ask the stakeholders what they wanted. And they wanted to see if Zcash D, the original Zcash daemon, which was a fork of Bitcoin, could talk reliably to Zebra. And as you can see, they could not. And that's what we were able to ascertain. We were lucky enough to have a little bit of a reputation to schedule that call, but this should still be helpful and still apply to you. So we did that, and we got the grant, and this is all the stuff, not all the stuff, but a sampling of what we found. They did not handle a small number of initial peers very well. There was a lot of messages to peers that were not rate limited. Download attempts were not rate limited. Disconnections were unreliable, very shaky. Out of range version timestamps were causing a lot of panics, and outbound messages were not rate limited. As you can see, most of these were fixed. This is just a really small sampling of the bugs that we found. I hesitate to call it a security audit because it wasn't as formal as that, but we really did run this thing through the ringer and find a lot of things, and a lot of things beyond this that I have to say were pretty alarming. And again, I'm not picking on people. As you can see, Zcash is awesome. Peer-to-peer networking is hard. And I want to really hammer that home. So yeah, this guy knows what I'm talking about right here. He's smiling. Okay, so that's not all. We found bugs in the Zcash, the original Zcash daemon. We came out with about 188 tests across 25 different suites of tests that we were able to run. If you look at the Ziggurat manual that we published, there's a symbolic notation for describing these tests using these kind of different types of arrows to describe the handshake going in different directions. And we threw some Prometheus compatible metrics in there because why not? The main trick that we were able to do this with was something called a synthetic node that we created. So we basically re-implemented only the networking layer of Zcash from scratch. So it's its own node implementation that just does networking. And that seems like reinventing the wheel, so why would you do that? And here's why. 3 reasons. One is the flexibility and independence. We did not have to wait for Zcash devs to do anything before we were able to execute. So we were operating completely independently of those teams. We were liaising with them and liaising with them well. The other reason is the black box testing. Sorry, these slides are a little outdated, but I'll just talk through it. So the black box testing is actually a feature. It's something that you want to see because even though we were able to run a node locally and introspect, the fact that we weren't able to do that, it was actually good because it was just the kind of blind view of what the node was doing and sending back to us. And then, kind of blanking on the third reason now that I don't have the slide in front of me, but there's a third reason and it's pretty good. So, that's basically it. So now we've moved on. We're moving on to Ripple. With the Ripple Foundation, we're basically doing the same thing. And if you look, actually going back to this, there was a DARPA report, the Trail of Bits DARPA report that talks about centrality. Has anybody seen this report that just came out? Look it up, and I think it's linked to in the updated slides, but it basically talks about different versions of centrality and different kind of ways that centrality can present itself. And one of them was dependencies. So we've taken care of that with the independence part of it. And then there's that. So yeah, working with Ripple now. And the main question is, should Polkadot get the Zcash Ziggurat treatment? And that's the kind of purpose of this talk here, is to pitch that to you guys and see, we're going to make a Treasury proposal for this. You should check it out, and you should look at the work that we've done, and if you have the means, you should vote for it. And I'm going to close, this is a pretty kind of a lightning talk here, but I'm going to close with this assertion here, and this is my prediction. It's the only prediction I'm comfortable making in the crypto space here, in that it's only a matter of time. I'm amazed that this hasn't happened yet. We've seen consensus layer attacks, we've seen other types of attacks, token layer, application layer attacks, but there hasn't been a purely network layer attack that a crawler plus some knowledge of networking flaw that can take down an entire blockchain network. And that's what we're here to prevent. We're not here to enable that. We're here to prevent something like this from happening. But I'm pretty sure that's what we're looking at. So that's all. And yeah.